Good morning, everyone. My name is Maxim Lecouture, and I am National Sales Manager for the Additive Manufacturing Group at Javelin. I am excited with all the outstanding content we will be sharing with you today. Javelin accumulates more than 20 years supporting customers in their process improvement strategies. Approximately 2,000 customers across Canada leveraged additive manufacturing to save significant amount of time and money. Providing customers with comprehensive solutions and services, we offer our partners leading-edge, end-to-end advanced manufacturing solutions from high-fidelity prototyping and direct digital manufacturing to product design, reverse engineering, and metrology solutions. Our team has the knowledge and expertise to take you to new heights. Following this presentation, you will have the chance to have a sneak peek of our virtual tour of our Advanced Manufacturing Center. Stay tuned. Now, let's pause for a second and ask yourself, do you have the most efficient process to confirm the designs of your products during the prototyping phase? Mr. Shuvom, former aerospace engineer, former SolidWorks engineer, and now engineer for Stratasys, will explain how to get the absolute most out of 3D printing for prototypes. We will be monitoring the chat, so feel free to ask any questions you may have, and I will interact with Shuvom to ask your questions to be more lively. Shuvom, over to you now.
All right, Max, thank you so much. Thanks for having me here. So yeah, if you guys put my screen up, we'll go ahead and start. So this is a presentation I call Making Your 3D Prints More Realistic, but not too realistic. And you'll see why here in a second. So my job at Stratasys is when people get their new advanced multicolor machines, I go in, I'm with the software team, and I help them make sure they can get the output, the realistic prototype output they want out of those machines. So I help them get that end result. But every time I'm in, helping people set up their processes and going through, they always ask me the same question. They ask me, how realistic can my 3D printed parts get? They ask me, what's the most realistic part we can print? And sometimes this is the wrong question. Because here's my first rule. The only reason to 3D print a prototype is to make a design decision. And typically, it's your very next design decision. So the question I ask folks when they want to decide what to print is this print realistic enough to make your very next design decision? And that leads to kind of a gradated levels of 3D printing, which I'm going to go through here. So imagine you guys were a small, industrial design firm, and you're trying to come up with a design for the next new hot game controller, like a PlayStation controller, an Xbox controller. You want to leapfrog ahead, and you need to pitch this idea to someone like Sony or Xbox or something like that. Everything I'm going to go over here, I've written a tutorial on earlier on, so if I'm going too fast here, don't worry about it. It's all written down on the web. Go to GrabCAD.com. You can search for the tutorial. If you go to Google, just Google how to 3D print realistic prototypes, and I'm the first video that comes up. So don't worry about taking detailed notes. All the little steps and tricks are recorded online for you at any time. And also, Javelin is recording this, so you can always play it back again. But let's go back to that design firm. Okay, so you're trying to come up with the next new video game controller prototype. You've got some ideas. And what I'm using as inspiration are my own PlayStation controllers from home. So this is what they look like from home. This is what we're going to try and get and go beyond. Okay, so that leads me to the levels of 3D printed realism. I break it down in 4 levels. Starting off, you've got realistic size and shape. Okay, you just want to make sure the size of the thing is correct. Going one level higher, now you've got realistic feel. You can see we're going to do stuff with those buttons. We're going to make those buttons soft as we make the rest of the print out of a hard plastic. And we'll make them feel like buttons, get a realistic feel. Going even higher, we're going to add colors. Okay, now you're going to talk about matching the right color, Pantones, things like that. That's a higher level of effort and result. And going even one level higher, I call it realistic everything else. This is when you put lights inside it, when you're polishing it, when you're putting weights and magnets inside it, everything else that's not 3D printing, right? So each of these levels is a quantum jump in effort and realism. What do I mean by that? In the first level, what do you need to make this happen? you just need a CAD file and any kind of printer. I put FDM printer here because that's what I'm using, but really any printer will work. You're just trying to get the shape of the thing. Going to level 2, now you have to add a PolyJet printer. You have to print in multiple materials, a hard and a soft material at the same time, and have them fuse together during the print. So now you need a multi-headed printer. Going to level 3, now you need some sort of software that outputs color. VRML, OBJ, the new format for 3MF. Okay, now you need a software that can do that, not just a CAD software maybe. And going one level even higher, now you're adding magnets and light and polish and even cornstarch. I'll talk about the cornstarch later. But you're going, again, another level of effort, another level of time. So as you're going through and designing your parts, your consumer product parts, you have to ask yourself, what's the minimum level you need to make your next design decision? That'll make you efficient and that'll save your time. All right? So let's go through these different levels. You guys ready? Level 1, size and shape. Okay, so when I started out, I use SolidWorks. You can use any sort of CAD system for this. I'm a SolidWorks person. I've been trained in SolidWorks for 10 years. So I made this model quickly in SolidWorks in 10 minutes. This looks like, the old Nintendo controllers we had when we were a kid. Okay, it looks pretty good on screen. It looks like my hands would fit around it, right? But the instant you print it out and pull off the tray, you can tell this is a bad fit. It just feels clunky in your hand. It hurts. It doesn't fit right? You can tell within 2 seconds of holding it, this is a bad design. So I went back to SolidWorks, and now I used the power surfacing feature. If you guys aren't using the power surfacing add-in, it's a great little add-in for consumer product design. It lets you do sub-D modeling and then add your SolidWorks mechanical features after that. So I did some smoother modeling. I came up with this, and when you print that out, you can see, if you can see in the little tiny screen here, it fits really, really well. It cups to your hand. The buttons are all in the right place. Okay, it's exactly the right size, right? So this one works. And you can find that out within 4 seconds of holding the print. But here's the trick for level 1. I didn't print one version and then the second version. I printed them both on the tray at the same time. And that's my rule for level 1, is print more than one size and shape at the same time. You don't want to do these in series, wait 3 hours, make a decision, wait 3 hours, make a decision. You want to do these in parallel, okay? That's more efficient. It won't affect the print time that much. An overnight print is an overnight print, and it will let you make a bunch of decisions really fast. You can tell what's not going to work right away. Previously, I was printing out a cell phone idea. We had an idea that if you put bumps on the back of a cell phone, you could kind of hold it better for gaming, kind of like those pop sockets that people use. And so here's what I printed. I printed a version of my cell phone with no bumps, a version with bumps, a version 10% larger, 20% larger, 10% smaller. And right away, that was an overnight print, but when you pulled them off the tray, you could tell which ones worked, which ones didn't. Imagine if I had done all these in series, one at a time. This would have been 3 days, but instead it was just one overnight print. Okay? So that's my rule for level 1. You're trying to figure out the size and shape of your part, just the general outline. Just, will this idea work? Okay? Print more than one size and shape at a time. It doesn't really affect the print time, and it really cuts down your design time. All right, and again, if you have any questions, we'll jump to level 2 now. If you have any questions on level 1, feel free to put it in the chat, and we'll monitor it as we go through. All right, let's jump to level 2. Now we're going to go a little bit higher and go to realistic feel. So this is a image I stole from Technor Apex. You can see their website down below. It talks about shore hardness. Some of you guys may be familiar with it, some may not. For our PolyJet machines, we have colors called Vero. Vero is our brand name, and those Vero colors are about shore 80 or shore 80D. Okay, so they're about as hard as a PVC pipe. So, and we also have white and black. I didn't show the white and the black and the clear up there, but those are pretty hard. But we also have colors called Agilus, and Agilus are shore 30A. We have white, black, and clear. Okay, pretty soft, between a mouse pad and a bottle nipple. Okay. So one way to approach level 2 is, for this controller, you're going to print the buttons in shore 30A, okay, nice and soft. You print the body in shore 85D, okay? That's the very basic level of feel. And you make it a multi-body in SolidWorks. The bodies just have to touch. There's no special thing you have to do with the PolyJet printer. As long as the bodies touch face to face, they'll bond during the printing process. but this is the very basic level. We can get better. So this is a graph I made showing the hardest, the softest buttons. If you print that solid Agilus button, even though it's 5 millimeters, it still feels kind of tough. It's like the nub on the bottom of your shoe. So then you start using some tricks we learned from our medical team. The medical team does this when they print surgery guides for doctors. They want to print a hand that feels like a hand. They start doing these tricks. And one of these tricks is they make the part hollow. This is a shell feature in SolidWorks, just a simple 2 millimeter shell. And anything that's orange will have support material on the inside. And we don't have to wash the support material out. The support material makes it squishy. So that's a little bit softer. It still feels like a shoe. But if you make a 1 millimeter shell, this feels soft when you give it a firm push. It feels pretty good. And then you have the unsupported shell. This is really soft. This feels like the nub on a stylus, very flimsy, right? So you can dial in, you have that one shore hardness, but you can dial in what you're doing to make it feel harder or softer. So just like level 1, you don't print just one of these at a time. I did a 1-hour test print, and you print a bunch. Okay, so here's some solid buttons. Here's some different hollow buttons, some unsupported buttons. Okay, I just want to see what they feel like. Again, we're testing ideas. We're trying to find out what doesn't work. Okay, so here's the results. The solid buttons, like I said, felt like a rock, no squish. But the hollow buttons with the 1 millimeter shell, they felt like a squish, and they felt like a real button. You can see the rear view. You can see the support material on the back there, the unsupported ones. Okay, so here's the results. Too hard, too soft, but this in the middle is the Goldilocks zone, right? For the application I'm doing, it felt most like a real button to me. Okay, and why are we doing this? Because if you look at the buttons we printed on the left, so here's what we actually printed in the 1-hour test, but here's what the actual controller looks like. I bought a used controller and took it apart to show what it looks like. In the actual controller, you've got hard plastic buttons over a very thin rubber spring, okay, less than 1 millimeter thickness spring. But my buttons are relatively thick. So I didn't try to match one for one the exact geometry of what's going on. Okay, we're using a different process. We're using a different style of printing, different CAD file, but I just had to have something that felt close. Okay, so I tested it in a little 1-hour print. Then I print an actual one, it felt pretty good. Here's the actual one right here in my corner of a screen. And then I had live testing, right? So one of my coworkers said, man, this feels close enough to test. My other coworker was like, this is better than the one I have at home, right? So again, you can dial in this feel based on some tricks you can do with geometry and, infill. Okay? And so that's my rule for level 2. It doesn't have to be exactly real to feel real enough. The buttons as they are real enough for us to take to someone and say, look, this is the next control we want to make. Do you like it? Okay, to get it past that executive. We don't have to go all the way and make these tiny springs over hard buttons. You could if you wanted to, but again, you're trying to do things fast. You're trying to be the first to market. Try and just test out this idea. All right, let's take a moment here to pause and talk about textures. So for a separate project I was doing, automotive folks, I know you guys have a lot of automotive folks up there. They love leather textures, especially on car dashboards. So I looked at a part in my car that kind of looks like this. This part isn't printed, but I said, what would I do if I was going to print this? Okay, so I made a similar part in CAD. Again, I love using SolidWorks. The process, here's one way to put textures. Lots of other programs have different ways. You can do it in Photoshop, you can do it in Rhino, you can do it in 3Matics. Lots of different programs have different ways. Here's one process. I put different faces in SolidWorks, isolating them to make sure they're using the split face command. Okay, I applied a 2D texture, just a black and white texture. And then I applied a 3D texture in SolidWorks. This is a feature that's new in 2019. Okay, it lets you actually bump and displace the part and make an STL out of it. You lay it out on GrabCAD, okay, just like you normally would. And then when you print it, that's the result. The picture in SolidWorks is circular textures. That was an earlier version. The red picture is actually hexagons. It actually was my third or fourth iteration. It came out really well. Just the texture wraps around the fillets. It feels really nice. Okay, it makes it look very realistic and not like a 3D printed part. So that's the one I'm showing here. Okay. So some tips on doing textures. This is for FDM really. What works and what doesn't. If you have textures on a vertical surface, work really well. Textures on an angle surface, depends on the angle. And textures on a horizontal surface, they're the worst. They don't work at all. And here's what it looks like when it's printed. So this is a little bow tie texture. On the vertical surface, you can see we have lots of layers. We actually have 10 layers of information for each bow tie. Okay, I'm printing at a 10,000th inch layer height. The bow ties are, 200 thousandths of an inch. So you have 10 layers to capture that information. Lots of fine detail. But on the worst version, you only have 2 layers. Okay, and the bow ties are only so high. They're only 2 layers high. So now you can see it just does not capture the intent at all, right? And this happens mainly in FDM. You don't have to worry about this so much in PolyJet. PolyJet, the layer height is 10 times finer, so you don't see this so much in PolyJet. But if you're doing this in FDM, watch out for this. You want to print the textures on vertical surfaces. Okay, so that was me using SolidWorks to apply textures. Like I said, you can also use Rhino. This is me printing out a version of the moon. The black lava plains are flat, the white mountains are raised. You can also do this in Photoshop. This is me printing out Westeros, or from Game of Thrones. I started with just a gray rectangular slab in Photoshop, put the map on there and bumped it. The blue areas stayed low, they were the seas. The light colored areas raised up, okay? So I'm not gonna go through and model every single island in Photoshop or in CAD. I'm gonna let Photoshop do that for me. So you can bump things out a lot of different ways. Okay, so that's level 2, realistic feel. The tips here are it doesn't have to be real to feel real. Think of how we fake those buttons and fake the softness of the buttons. And also, textures go a long way. There's just something about textures that fool the eye. These repeating textures, it fools the eye, it fools the fingers. Okay, it doesn't look like a 3D printed part anymore. It looks really realistic. So definitely, if you want to jump up your level 2 game, add some textures to it. Lots of different ways to add textures. All right, before we get into level 3, I'm going to put a big intermission here, and we're going to talk about modular design. Okay, this is going to be important in how we apply colors. And again, if Max and if you guys have any questions, feel free to interrupt me on the chat. Okay, but we're going to talk about modular design here before we jump to level 3. What do I mean by modular design? Modular design means you have a common middle, and then you have a top that can come off like this, and you have a bottom that can come off. We actually learned this trick from architects. Architects use this to put facades on their 3D printed buildings. That way, the middle is the thick, beefy part. It takes 8 hours to print some of these architectural buildings, but the facade is very thin. It only takes an hour to print the facade. So if you design your part so that the top and bottoms come off, you can switch out these facades and swap out for any different color you want and don't have to print the 8-hour thing again. You can just print a 1-hour facade. Okay? How do you do it? Again, I'll show you in SolidWorks. You start off with the original body. You make a copy of it. The black is the copy, and then you shill it out. The original body is still gray. You split it into an upper and a lower, again, using a sketch to split the part. Okay, so now you got an upper, which is purple, and a lower, which is black. And then finally, you make a copy again of the upper and lower and subtract those from the original body. So now everything will fit together like a glove. Okay, there's no overlapping volumes. How tightly do you make them fit together? Typically, the rule for any kind of 3D printed thing is you leave 1 layer height between parts that have to fit together. In the J750, our layer height was 27 microns, so I left 27 microns between the parts every place you see a red arrow. I actually went through in SolidWorks, you do some cutting, you just leave some space. Now, this was a very tight fit. I had to actually do a lot of sanding between the top and the bottom part here to get this to fit. So 27 microns, 1 layer height is a very tight fit. If you want it a little bit easier, maybe you do 2 layer heights, but that's a good rule of thumb. You leave 1 layer height of thickness at least, and then go up from there. And so did it work? I made this GIF before I realized I was going to be on camera for you guys, but yeah, it works. You can snap it on. It fits nice and tight. Okay. So now what can you do with this modular design? I can take a file in GrabCAD and I can test it on my buttons, right? I can make a facade in GrabCAD, or a facade, this is a bumped out in SolidWorks, okay? I can make another facade, put it in GrabCAD, and test it in an hour. I can make a colorful facade, put it in GrabCAD, and test it in an hour, right? This wouldn't have been possible if I was printing the whole body over and over again. And so that's what I did here. Again, this is 1 day's work for a J750, right? You can put all these parts, print them overnight because they're really thin, and they'll be done when you come in the morning. Okay, so think about each of these taking 8 hours instead because it's printing the whole controller. It's crazy. So this is the benefit of modular design. It opens up so many possibilities for color studies. So now having talked about modular design, let's talk about how to do those actual colors. Okay, so I said before, to do colors, you need some sort of software that can output a VRML, a WRL file, an OBJ, or a 3MF. 3MF is the newest and most modern. OBJ is kind of a wider standard. VRML, very old standard. But what softwares can do this? Well, the first one I learned was Photoshop. You can actually take those 3D files into Photoshop, put a logo or a texture on there. This works great for flat faces, for very sharp logos, your company name. I would probably use Photoshop on something. Rhino is good for wrapping things around. So if you wrap around all the different surfaces of a body, if it's multi-body, if it's like very complex, I'd probably use Rhino. But oddly enough, a dark horse in this is SolidWorks, right? SolidWorks just recently, they kind of added 3MF support. We recently added support to import the 3MFs. So SolidWorks is actually a surprising entry in this. This is how it would look in Rhino. I make the shapes in SolidWorks so you can see my modular design. I add an American flag JPEG, and I put it all in Rhino. Okay, so I bumped it in SolidWorks. I put the flag on in Rhino because you can't put a flag or a texture on a STL file on SolidWorks. It doesn't work there. It'll work in Rhino. You put it on a tray in GrabCAD print, and you print it out. Okay, another facade. You can easily test it. That's how I used to do it before the start of this year. Now, if I'm working with a non-bumped, non-texture design, I just go to SolidWorks and I export a 3MF. Okay, super easy, just one click, save as, export, and everything's zipped up for you. So this is really my easiest path now. You can see I've got multi-bodies in SolidWorks. The different blue buttons are blue. I've got a face texture, which is the map. Okay, this is my easiest path now. Oh, wow. Okay, awesome, cool. All right, we're gonna get through this. So lots of different ways to do, CAD and texturing and to get to VRMLs and OBJs. But like I said, this is my easiest path now. So you guys are learning about SolidWorks 2021. I think this is perfect. Try this if you're using a color printer. All right. So talking one last time about realistic colors. If you don't know what color to print, we have a swatch tool inside GrabCAD print. You put your target color, you put some sort of radius around it, and you can print out a swatch which shows you what those different colors will look like on the tray. And when you actually print it out, you can go to your client and say, do you want this color or do you want this color? I'm trying to match the color of a Pepsi can right here. So you can have the client circle which color they want because things on the printed out are different from how they look on the screen. RGB on the screen is different from CMYK on the print. Okay, one is additive, one is subtractive. So if your client can circle what color they want, that'll help you figure it out. Some people also use Pantones. We support Pantones as well. So you can choose the Pantone. This is me printing a green Pantone next to my Pantone book. Looks pretty close. Okay, so those are my rules for level 3. Is have a software that prints out VRMLs, OBJs, and 3MFs, and then define your colors with an actual print or Pantone before you start. Okay, last one. We've got about 2 or 3 minutes left. Let's talk about everything else. Okay, you want your parts to light up from the inside? You can buy these lights on Amazon, really small. You can put them inside your part. That's what I did for the controller. You can even put, if the part weighs too much, you can put weight-reducing pockets on the inside. You can even put magnets on the inside, right, to make them snap together. If you want your parts to be shiny or clear, you can put a spray paint of Rust-Oleum. You can see the difference between painted and not painted, okay? So the clear enamel really, really helps with the reflections and refractions. And finally, I was talking about the cornstarch. If you ever used Agilus before, Agilus is a little bit sticky, kind of like leather, right? But buttons are supposed to be smooth. So what did I do to make the Agilus smooth? I actually brushed cornstarch. This is a trick, someone at the office told me. The light layer of cornstarch makes the buttons less sticky. Okay, it makes them feel more like plastic. Okay, so the things I do for you guys to prove this out. So that's how I got to this print. And it's probably the most realistic print I've done. A lot of people couldn't tell a difference between a real controller and it, but it definitely took a lot of work to get there. And maybe all that work isn't appropriate when you're just trying to find the shape or the idea of your controller first off. Okay? But the point is to do the work really fast. This is all 1 week of work. You can see I started off with a very coarse design. I went to modular. I started adding some colors and some textures. I tested the buttons. Okay, this is just 1 week. I can make more models in a week now with a printer than I could in a month, using other methods. Okay, you want to test those designs out really fast. So wrapping up now, everything I've shown you is on GrabCAD.com. I've made different tutorials about how to match color, how to make texture, prototypes, all there. And we'll talk about the levels of 3D printing one last time. Okay? The very first level, you're looking at basic CAD. You're just trying to see if things fit. Okay? But then you go higher. Now you're dealing with shore values and Agilus. Now you're dealing with the hollow tricks on the buttons. You're dealing with texturing programs. Okay? It's more of effort. If you want to go higher, I'm going to put a wedge in there. Think about modular design. Now you have to do advanced CAD to get those facades. Okay, a little bit of copying and splitting. Going higher to level 3, now you have to deal with VRLs, OBJs, 3MF, the RGB to CMYK problem, Pantones, UV mapping. Okay, these are all problems that come up at level 3. Sometimes it's worth it, sometimes it's not. And then going to level 4, now you're talking about post-processing and really model making, polishing. It's a lot of non-3D printing skill. But if you really want to get that highest level of realism, that's where you have to go. Okay, it's a lot of work there, but sometimes you get the most beautiful models that way. All right, so that's all I've got on making your 3D prints more realistic, but not too realistic. I've got my email there at the bottom. Let me know if you guys have any questions. And Claudia and Max, do you guys have any questions in the chat, or are we done?
We're all good on the question, Shuvom. The questions have been answered live in the chat, and we have our emails there if any more questions pop to your minds. Thank you very much, Shuvom, for this great presentation. I am sure some of you might have discovered now that 3D printing prototypes has reached a new level. We look forward to dive deeper in this process with you. Please feel free to reach out. Thanks, Shuvom. Now, let's see a quick sneak peek video of our Advanced Manufacturing Center in Oakville.
Welcome to Javelin's Additive Manufacturing Center, or AMC as we like to call it, located in Oakville, Ontario. This 3,000 square foot facility has both metal and plastic 3D printers, as well as post-processing systems, RTEC scanners, and universal laser machines. Our systems are constantly at work fulfilling service orders managed by our professional services team. Click on the hotspots to look around and learn more about the hardware and services we offer in our AMC. If you have any questions or would like to learn more, do not hesitate to reach out for more information.